So, welcome to the Quint launch party. If you're here and you don't remember what Quint is, let me remind that real quickly. So, Quint is our modern specification language. It's an executable specification language based on TLA plus, a very nice formal specification language. Um, I'm saying specification language way too much, sorry. So Quint is our language, and it helps you build more confidence in your protocols, in your algorithms, in your software systems in general. And I'm the main developer, the lead developer of Quint, and I'll be hosting this event today with our two amazing guests. So let's get started. We have a bit of an agenda here. We start going over Quint's journey, what happened this far, some recent developments on Quint, what's new from like the V1. I'll do a quick demo, looking into Quint in practice. Then we'll have a nice chat with our guests. And finally, a Q&A and a wrap up. So getting started with Quint's journey. So early stages of Quint, Informal was founded, and right from the bat, we had strong alignment with TLA Plus. We were writing TLA Plus specs for our protocols, for example, Tendermint. We were using TLA Plus a lot right from the beginning. But we noticed that software engineers usually struggled a lot with TLA plus. They thought the syntax was very hard to learn. They really didn't want to onboard. They struggled a lot. And this was a big problem for us. So we wondered, how could we help TLA plus? How could we make it better? We considered different ways to improve the tooling around TLA plus, to add more to it. But there were various challenges. It was very hard for us to work with the tooling. It seemed like very hard to do the things that we wanted to do and achieve that around TLA plus. So instead, we came up with the idea of a new language, right? Taking what is good from TLA plus, which is a lot, and then changing the bits that are not so great, which is mainly like the syntax and the tooling. So this is where Quint was born, trying a new language that was more accessible to engineers and that anyone could use. And this was on May 2021. Back then, we had only like a manual describing the language, parser, and the design principles for the language. And a few months later, I joined Informal. So I was saying we, but it was actually like I was not part of this group until here. But this is where I joined, and I had like a bit of a background building tools for TLA Plus, and also a different background like in compilers. So I liked that kind of thing. And I picked this up and started working on this language from this manual. I wrote like name resolver, the type checker, and all of that stuff. And by December of 2022, we had like this first version of the compiler that we open source and put out into the world. That's also when we had to pick a name for it, which was super hard. And we came up with Quint, also designed this beautiful logo. And the code was out. But a few months later, we had the first version of our simulator, which was the thing that executes the Quint spec or simulates them. And this is when we could take value, use Quint and get value out of it in our internal projects. And then we started using Quint. And a few months later, we were able to model check Quint specifications because we had the integration with Apalache finally working. So this was like our first roadmap for Quint. This was like the first complete version of what we wanted. And since then, we've done some new developments, right? So what happened since that first version was out? Quint now, on December 2023, we did this announcement on Hacker News and started to get attention outside of our little bubble. And this was huge, guys. Like, if you have a project, make sure you announce that on Hacker News in a good way, because like this was super great for us. If you see the two verticals here on the GitHub star history, the two verticals were announcements on Hacker News. So it's really, really great to get some attention. So we are officially out. And then we also like started doing some more like marketing things, including building our website, which was out in July 2024. Our website, quint-lang.org, has a beautiful landing page, has a bunch of documentation. So we invested a lot on the website. And also especially maturing the tools and the documentation. So instead of like just adding a bunch of crazy new features, we just wanted to make sure that what was already there was very stable, worked. For example, we fixed all of our known type checker bugs. There are no known type checker bugs at this point in time, and also many other bugs across tooling. So it's a very mature stage now. Also added some real world examples. And by now, April 2025, we realized that Quint deserves Rust, and we wrote a Rust simulator, which is actually much faster. Initially, like right now, we are getting about 2 to 3 times speed up. We expect this to improve even more once we make more optimizations. This is just like V0 of this simulator. So yeah, so this is being launched actually right now. So this is not launch as of this minute, but we are going to do this together. So I have a terminal here, and hopefully the live demo gods will bless it and this command will work. So this is supposed to push, it works, amazing, not very complicated. So this pushed our tag to GitHub, which automatically triggers a workflow that posts this to NPM. So in about like 3 minutes, you'll be able to download the new version from NPM and start using the new Rust backend. So hey, we did this together. Quint in Rust is released. That's the point of the launch party, maybe. Okay. Also, while we were doing all of this, many projects started using Quint, started writing their first Quint specs and get value out of Quint, finding their first bugs with Quint, and especially like understanding their protocols and getting more insights on how things are happening by using the executable specifications written in Quint. So here are a few of those amazing projects that have been using Quint over this past couple of years. Did I skip something? Oops, no. So now we are going into the demo. I think we are good on time. And yes, so for the demo, I want to start from our website, okay? Because everything I'm showing you, I'm going to go very quickly here because we don't have much time, but everything is on the website. So we can go back later and learn with more time, okay? So I want to start here from the landing page. This is the landing page, and we have 3 special words here, features of Quint: executable, abstract, and modern. I just want to go over this real quickly. So if you're currently writing your specifications for like your protocols or algorithms, if you're writing them in English or Markdown or both, it's probably a good idea to try to write them in Quint. And why is better? Because in English and Markdown or even in papers, sometimes you forget to specify, like to include the definition of some name, or maybe we make a mistake in our types. And we are not going to know that unless like we review it really carefully. But with Quint, it checks your names, checks your types, and you can actually execute. So it's much easier to find problems in your specifications if you write them on an executable language. If you're not writing specifications at all, you're just like, no, programming languages are good enough. I'm just a programmer. Programming is fine. Just know that like writing things on a more abstract level on a specification language, it's very powerful because you define only what you care about. You don't have to define every single detail, and then you are able to reason on a much more abstract level, as mathematicians do. So it's very powerful to abstract away from the code. Or if you're already perhaps writing specifications on existing languages other than Quint, you might want to consider trying Quint because it's more modern. So that's the main advantage here. It has a much more familiar syntax for engineers. And we have a great CLI, have great integration with your editor. So if you type something wrong in your editor, it will tell you. So it really feels like a modern tool, not like many other specification languages I tried where you have to use this old GUI tools that feels very, very old. So here are just some comparisons of Quint with other stuff, but let's jump into the actual demo. So I want to go here into the documentation, which starts in this like why page, which explains a bit why you should use Quint, but let's not go over that right now. Let's jump into this. What does Quint do? So this explains what Quint is, right? So Quint takes 2 inputs, a model and some properties. These are both written in the Quint language, okay? So with these 2 inputs, the Quint can use either a model checker or a simulator to tell you whether the properties are true in the model, so all good, or if there is a violation. And every time there is a violation, Quint will tell you exactly how that violation happened. So it will tell like we started in state 0, and then we went to this state, and then at that state, and then that state. And then that's where we reach the violation. So there are no false positives. All violations are actually like concrete and explained here. So we need model and properties. So models are just state machines and properties are just formulas. So those are just very simple things. And to define a model, we need a language to define a model, which is what Quint is. Okay, so Quint defines this state machine. So if you jump into this section here, writing specifications, the first one's language basics. So let's look at this a little bit. So most of Quint looks like a normal programming language, but it does have a few special things because it's not a programming language. It's not made for you to write programs. It's made for you to write state machines. Okay, so we have some constructs to help you write those state machines. So first of all, like the prime operator. Prime operator will refer to things on the next state. So you can write expressions like x in the next state equals to x in this state plus 1. These types of assignments, they also don't have any specific order. So all of this happens simultaneously. It's like a transition in your state machine. And you also have these special definitions, init and step. So init will define your initial state of your state machine, and step all of your transitions. So it's just a language for defining state machine. Now that we look at this, let's see the spec that we are going to work on today. So this spec was inspired on Hilal's Wayne's demo on this blog post that I really, really like. So shout out to Hilal if he's here. Yeah, so I just took inspiration from there. It's not the same spec, just shutting out. Yeah, so our state here, so we have a state machine. Our state is composed, oh, sorry, I should tell you what this is about. So the spec is about launching the Quint rocket into space. So we have this rocket, but it has limited tickets. Okay, so we have some tickets here for some people, and these people can offer their tickets to other people. Like if they don't want to go, if they have extra tickets, they can offer the ticket to someone else. Okay, this is the context. So the state machine has two variables here on the state. We have a set of offers that exist at any given time, and also we have this map of ticket holders, so we can see which passenger holds which tickets at any given time. Okay, so these are our state variables. Yes, this is our state, and then we have our transitions, which are here. So how the state machine evolves over time is that some person can propose their ticket to someone else, which is this action, or someone can accept an offer that exists, right? So those are the two transitions that can happen. And here's how the core state machine is defined. So we start with init, and then we have step. So init is the initial state. I just defined some arbitrary initial state here where ticket 1 belongs to me, ticket 2 belongs to our guest Julian, and ticket 3 belongs to our guest Giuliano. And then I have some extra tickets that I can give away. And then the step is either someone can accept an offer if there is an offer. Okay, so if the size of offers is greater than 0, then there exists some offers and then someone can accept one of those. Or without any condition, someone can propose to give their ticket away. So this is our state machine, just that until here. So now that we have a state machine, let's load the state machine into the REPL like this, so we can see how things go. Okay, so I'm on Quint REPL. I can evaluate any expressions here, evaluate any expressions like 1 plus 1. So let's interact with our model. So first, let's initialize state machine. So I call the init definition here. And now I can inspect our state variables, for example, offers, ticket holders. These are the initial values, okay? So let's say, so ticket 4 belongs to me. Let's say that I will propose this ticket. So it belongs to me. I'm the one proposing, and I will propose this to Ocean, because poor Ocean doesn't have a ticket yet. So yeah, that worked. And now if I see the offers, this is the set of existing offers. Let's say now that I want to accept that offer. So let me first take that offer out of a set. So let me do val offer equal offers. As I only have one element, I can do get only element. And then I can take the element out of the set. And now I have it here. Let me say that Ocean accepts this offer. So this worked. And now if I look at who owns or who holds the the ticket number 4, that's Ocean. Okay, so I offered my ticket to Ocean and she accepted and things worked. So this is a nice way to interact with the system, with the protocol, with the algorithm by using the Quint REPL, make sure things are working as we expect. Let me get out of the REPL here. And I will now go back to the website, which is this one. Okay, so we went to the introduction a bit and we learned how to write specification kind of quickly, but yeah, that's what we did. We wrote the model state machine, and we actually already seen this interacting with the REPL. So this is one way of using specifications, right? This is the section here. There's another way of using specifications, which is checking properties, probably like the main way. So let's do a bit of that right now. So whenever I have a new specification, the first type of property I like to verify, to check is some interesting scenarios, actually. So not properties that I actually expect to hold for my model, but rather like some things that I want to see happening, right? So I want to see how this happens. One interesting scenario that I determined here is that I own all the tickets, or I hold all the tickets, right? So I think it's interesting. I want to see how this happens, and I want to make sure that this can happen, right? If this cannot happen, then perhaps there's something wrong with my model. So I wrote a property here, Gabriela owns all tickets, and I'm going to say this is not true. So I'm telling Quint, like, I don't think this is ever true. I think this is completely impossible. Gabriela never can hold all the tickets. And then I can run it, and Quint will tell me I'm wrong. This is actually possible. So I'll do Quint run, name of the file, and an invariant. And what I'm going to do here is the counter example invariant. And Quint tells me I'm wrong. So Quint tells me violation. And it tells me actually Gabriela can hold all the tickets, right? So I can see here an example. There's 7 states in. Gabriela has all the tickets. You see here. So this is interesting because I can understand how this can be achieved, right? How can my protocol reach a state where consensus is reached? So I just tell simulator, oh, consensus is never reached. And then it tells me, oh, no, it is reached. Look, here is consensus, or here's where Gabriela owns all tickets. So this is an interesting way of finding interesting scenarios using Quint. But that's not really checking properties, right? Let's go into actual safety properties of this little system here of offering. So I wrote an invariant here called offer safety. So it says that for all offers in my set of offers, the giver of that offer is the holder of the ticket, right? So there cannot be an offer from someone who doesn't own a ticket. Let's run the simulator for this property. So offer safety. It found an issue. Interesting. So it actually means that my system is not as safe as I thought because offer safety is violated. What happened here? We had the state here where Gabriela offered a ticket to both Giuliano and Ocean. So I said, like, oh, I won't use this ticket. Either of you can have it. I offered to both of them, ticket number 1. Then what happened here was that Giuliano accepted my offer, right? So you can see here that Giuliano has ticket number 1, and then this offer is gone, but the offer for Ocean still remains. So there's still an offer from Gabriela to Ocean of ticket 1, even though ticket 1 belongs to Giuliano. So how can Gabriela be offering that to Ocean if it belongs to Giuliano? This is wrong. This cannot be happening, right? But my model is not good enough. So yeah, so if you want to fix this little bug here in the model, the code is available. Ocean has the link. She can share it on the chat. Yes, you can play around with this later and maybe try to fix it. So one thing I did for this specific bug, I'll just scroll down here and then go back later. I have this specific run here. So this is another feature by Quint that is not present in other formal methods usually, not the ones that I know. But this is like a kind of way to specify a specific run, a concrete run, and we can test that this is true. Test that the expectation that I have here holds. So I have a run here where trying to reproduce a similar bug here, right? So Julian offers his ticket to both Ocean and me. Then Ocean accepts her offer, and then I accept that offer. And then at the end, my expectation is that Ocean does not hold, right? So is not the holder of the ticket. or any ticket. So basically here, I can show how I can steal Ocean's ticket, which is not fair. So this is a concrete run that I can reproduce here. So I can make sure that the expectation holds by doing Quint test and then just match the specific test and the name of the file. And then Quint tells me this test passed, which tells me that it is true that we can have stealing. So this is a useful way to show people specific things that can happen in the system or the protocol. But let's go back to properties because I'm not done with that. Because I have another property here, which is a but simpler property that just says that no tickets are lost. So at any given point, it should have the same 5 tickets that we have from the beginning. There shouldn't be any tickets created or destroyed. So let me do Quint run, name of the file, and then my invariant here is no tickets lost. So this I can run and it finds no violation. It says okay. Oh, also I can run that with the new Rust backend. So if you want to run, so by default we are still using the usual TypeScript backend, but if I do minus backend equals Rust, that's all it takes for us to run the new Rust simulator. So gives me a similar result here, but this uses the Rust backend. Okay, so we didn't find any violations. Does it mean that we don't have any violations at all here? Not exactly. It just means that we're not able to find a violation using the simulator, which just inspects like 10,000 different samples, not all of them. If I want to be 100% sure, I have to come here and switch run into verify. This will call the Appalachian model checker. Okay, I have to, yeah, sorry. This is supposed to be faster. I just made a mistake. So the Quint verify will actually run the Appalachian model checker in the background and make sure that there are no violations at all in any possible scenario. So now I have formally verified my no tickets lost property. Oh, what if I don't want to use the Appalachian model checker? What if I want to use some other tool for TLA plus, like TLC? It's not a problem because our Quint specifications can be transpiled into TLA+. So I told you it's like very inspired in TLA+. It holds the same formal semantics as TLA+. So we can go here and say compile. And I want to say also target equals TLA+. So if I run this, also again, need to take a bit more time because I forgot to run the other thing. But it will run the Appalachian in the background because that's how we use the compilation thing, but you don't, that doesn't really matter. But here we have the TLA specification corresponding to that Quint specification. So we can use like TLC or any other TLA plus tooling that you want, because we can transpile Quint into TLA plus. So I think I covered all I wanted with the demo. And yeah, if you want to play around with this a bit more, the link is available to download the spec and play with it. And also, I also wrote down all the comments that I ran here prior to try. So now we are done with the demo, and we are going to talk with our amazing guests. So starting with Giuliano. Giuliano, if you're here, can you please just quickly introduce yourself, maybe say a bit about what you're currently working on, so we can jump into the questions, please.
Yeah, hi everyone. Thank you. Thanks a lot for the presentation and for your work on Quint. First, I think it's a very exciting tool and very important work, making specification and verification more attainable for engineers and developers. So yeah, about myself, I've been doing research and engineering at the intersection of formal methods and distributed computing for a while. So a PhD in that area, then I was a postdoc in that area for like 4 years. Then I was a research engineer at a company called Galois, and now I work at the Stellar Development Foundation, where the foundation maintains the Stellar network, which is a blockchain network. And I'm a senior researcher there in our research group. And so what I do there is like a mix of several things. I participate like in the research community, publishing papers and so on, like academics. But I also help the engineering team with problem in distributed computing and software reliability that they have. So yeah, that's briefly what I do.
Yeah, very good stuff. Thanks for sharing. Let's jump into the questions. The first question I have here. Can you share a specific instance where formal methods significantly impacted the outcome of a project you were working on?
Um, yeah, so I mean, here it's been a very long running project. So at Stellar we're developing amongst other things the Stellar consensus protocol. And so this started back in 2014 when I was not at Stellar. There was no formal methods or specifications involved at the time, but it was it was kind of difficult to get people to understand the protocol, to believe that it actually worked. And so the first time I got involved in Stellar was actually during one of my postdocs back in 2018, I think. And the goal there was to try to formalize the protocol and get people to understand what it's actually doing. Um, and so this was a year or more long project where we formalized the protocol. At the time, there was no Quint wasn't around. Um, so we used a mix of the Isabelle, which is an interactive theorem prover, and a tool called Ivy. And so we created a model of the protocol. We developed a proof that some correctness properties held, and so this was instrumental in several ways. So the first one is that we actually, by doing the formalization, you have to remove a lot of irrelevant details. You have to get to the core of things. So it improved a lot our understanding of the protocol, but also it convinced the academic community that the protocol was actually sound and correct. And this was very important to us being able to publish actually a paper about the Stellar Consensus Protocol at SOSP in 2019, which is like one of the most competitive systems conferences. It also made us realize that the protocol did not satisfy fully its intended properties, but we were able to characterize exactly what was going on. And so this was about the liveness of the consensus protocol. So we thought that the consensus protocol guaranteed liveness, but in fact, it only did so if we could assume that the potential malicious attackers that were in the system eventually went away. And so this was important to identify because this meant that participants in the consensus protocol have to keep an eye, an especially keen eye on what the other participants are doing and maybe exclude them from the system. Otherwise, they could just block the progress of the system. So that was
Yeah.
the first. Am I going too long?
No. Sorry, I thought you were finished. Yeah.
Yeah, and so that was kind of at a high level, but then back in 2019, and then we continued since then work in formalizing more concrete aspects of the protocol implementation, and uh, using TLA and later a little bit of Quint actually. And so one thing that we found was a performance bug. So by writing a specification and discussing it with engineers, we realized that some part of the protocol called the nomination protocol didn't really follow the specification. And this actually was a performance problem that was fairly significant. Yeah, and now we're working on some improvements of this consensus protocol. And it's very critical to the Stellar network because if there's a problem, the whole network stops. And so engineers are a little bit worried about making changes to the core consensus protocol. And so recently I wrote a TLA specification of a new version of some part of the protocol that's optimized. And I wrote in parallel a Quint specification, and the engineering team is going to start working on that soon. So I'll get some data on the
Yeah.
on what they prefer. I have a feeling it's going to be Quint.
Yeah, please tell me. Please tell me any feedback that they have. It's very interesting to see.
Yeah.
Yeah, that's very interesting to know. Thanks a lot for sharing that. That's a very interesting projects you're working on.
Thanks.
Can we move on to the next one? Okay, so this one is a bit more about Quint. How do you see Quint evolving to address these challenges you have encountered with other formal methods tools?
Yeah, so I think there's maybe two things that I want to point out. Uh, First is that that's what engineers are always asking is the testing, right? Can you use specification to test the actual system, and how easy or hard it is to do that. So I don't know if we can do something at the language level here, or if it's more a tooling issue. But any improvement on that front, I think, would be quite significant towards pushing adoption. Because I mean, yeah, just how do you keep, for example, a spec in sync with the code, and it can be too much effort, otherwise the engineers will not do it. Right? So
Yeah, that's a
that's.
very good question. Yeah, I can talk a bit about that quickly.
Mhm.
Because what the one step we took on that direction was adding the MBT flag, which just helps to generate some additional metadata on the traces to help reproduce them against the real spec. So there is this problem of connecting the specification with the program is like super hard, and a bunch of people are trying to address it. But so far, the most promising way of addressing it seems to be model-based testing. So generating tests based on the model that run against the program. So they help you like help with confidence that they match, right? So I can actually very quickly show here with the run command, you can do minus minus MBT for model-based testing, and then
Mhm.
it will generate these two additional fields here on top of the others, which is what action was taken and which data was picked in the non-determinism pick. So you can see like, oh, we did accept for this offer. So if you have like a program that implements this, can go there and have this data here. This it can be exported to JSON, so you can parse that and then call your program's accept with the this offer, and then see if the result state matches what we had here. So this is what how we have been kind of addressing this problem inside Informal, like
Mhm.
in our audit service, like when there is this necessity of matching the specification with the program, we generate this kind of tests and then run them against the implementation.
So then you manually write a script, I guess, that parses this scenario and calls your implementation.
Yeah, for Rust, we actually have a library that automates this parsing already. We don't have those for other languages yet, but they should be
Hmm.
super easy to do. So like in Rust, you can just like tell how your data structure is supposed to look like in Rust types, and then it parses automatically, and then you can call your things.
Yeah, great. Yeah, I think that kind of tool is really important for getting adoption. So
Yeah.
um, yeah, and then maybe another thing, which is maybe more of a language issue, I wanted to discuss is I think this came up in a discussion we had with Gabriela recently, where we were both looking at a system, a protocol that manipulates graphs, and it was not that easy to represent graphs and, I don't know, functions like find cycles in graphs or find paths of interest, and so on. And
Yeah.
this is a common problem, like both in TLA and Quint, I think. And in TLA, the way I was doing it was using recursive functions. So you can write recursive operators in TLA, but it can get a little bit mind bending to write everything using recursion. And so I don't know. I was wondering if maybe there was this little sub language hiding there that could be added to maybe both TLA and Quint, or you'd be able to more easily specify operations on complex data structures.
Interesting. Yeah, on my mind, the solution for that is adding recursion. The reason why we don't support recursion in Quint right now is because Apalache doesn't support recursion. But
Hmm.
we'll talk later about how we are improving the integration with TLC, which supports recursion. So we could, in theory, add recursion to Quint. We're still thinking whether we're going to do that, but it's one option to like address that problem. I guess you're thinking even like farther beyond than me, where like there might be something even better than recursion. Maybe we could have some sort of like native graph structures in Quint with like some libraries or something that could make it even better. I think recursion already solves most of the problem because recursion is at least like one decent way of dealing with graphs, right?
Yeah, I mean, at least you can do. you can express what you want, but I'm just a little bit afraid that having those complex recursive functions all over is not going to be very user friendly. And so I was thinking
Mm.
maybe if we could do iteration instead uh, of recursion, that would be much more user friendly. We read some little for loops and all that instead of recursive functions, but that would require a kind of little sub language to do that doesn't exist.
Yeah, definitely. Yeah, something interesting to think about. Thanks for bringing it up. So it's interesting discussion here. I want to move on to the next guest. So thank you a lot for your participation, Giuliano. Uh, and now we'll move on now to our next guest, which is Julian. So Julian, if you can also quickly introduce you and tell us what you're working on currently.
Yeah. Hey everyone, Gabriella, thank you for the presentation. So I started as a founding engineer at Duality about 3 years ago. They were building a on-chain DEX in Cosmos. We were since acquired by Neutron, where I've continued to lead the DEX development. And in that time, I've spent a good amount of time working with the informal folks on audits, and obviously in the context of an on-chain DEX, correctness has been incredibly important when we're dealing with user funds in a really complex system. We've put a huge amount of effort into trying to ensure that we have a perfect or as perfect as possible system. So yeah, Quint's been an exciting tool to sort of further those goals.
Awesome. So yeah, in that context, can you tell us a bit about how Quint is adding value to, or Quint could add value to security audit, and why you have chosen this type of audits?
Yeah. I guess the first piece is prior to incorporating Quint into sort of our testing flow, we didn't really have any formal specification. So I think the first piece was simply taking all of our code and distilling that down to a formal specification, like allowed some amount of like just visibility into the whole system. It's a much more terse definition of the system. So it's just easier to see how it all came together, and explain that to, I think, for example, like the folks at Informal, like rather than having thousands and thousands of lines of code, we were able to distill that down to this small specification. And I think the act of actually just like writing out that specification, helped sort of point at where there might be issues. And then Gabriella, kind of as you hinted at, like it's kind of the best of all the worlds that we get to have this specification and then actually run it. The other piece and kind of how we kind of came to Informal asking about what was available in terms of this sort of formal specification and testing is we have this like very, very complex state machine with all these different inputs and all these different ways that the DEX can be interacted with. And what we were finding is, despite having unit tests and integration tests, there were these long tail issues, where some very complex set of actions was potentially resulting in a problem. And sort of in unreleased versions, we were realizing that there was actual bugs there. But there was also just sort of concern that like we did not have a way to fully cover the entirety of the state machine, particularly like deep downstream. So being able to build a Quint model and test, can't say the entirety of the state machine, but like a much bigger chunk of it in an efficient way was really huge to like build up a little bit more certainty in terms of the actual correctness. And again, to sort of see that state machine on a specification level and kind of pick out where there might be issues was much more powerful than trying to do that in the code, where there's just the volume of code and then the amount that sort of gets hidden in Cosmos SDK and other libraries, just sort of obfuscates like some of the potential hotspots. And then lastly, in terms of just actually like writing the Quint, I found it incredibly easy. It was just pretty natural to jump in and write Quint. But before my time at Duality, I know we tried to use TLA plus, and some of our engineers were like very daunted by using TLA and just, sort of more specialized knowledge required to jump in. So really nice to have something that the folks at Informal could write these models and I could just read through in like a very human way and then kind of augment. And I guess the last thing I'll quickly say is, sorry, jumping around a little bit, but like with our own integration tests, like with these very long tail things, we tried to write our own state machine and replicate everything. And what we found there is you write a test and it fails, but there's no really easy way without putting in like a million print statements to actually understand the sequence of state transitions. So Quint obviously does a really nice job of giving you this nice readout of the state transitions, and you can kind of walk through and see where things are going awry, which made kind of debugging and like introspection into the model much easier.
Yeah, very interesting. Yeah, thanks for sharing. I have a couple more questions. I guess you talked a bit about this, but how do you compare this experience of discussing protocols and the changes of those protocols using a Quint spec versus the traditional ways or however you used to do it before?
Yeah. I think it's actually just given us a bit more process for how we actually do that. Prior to Quint, it was kind of write a very, unfortunately, loose spec and then usually just jump into building the whole thing. And then write a bunch of unit tests and integration tests. And then if there was concern, go to Informal or another auditor and have them go through it. What we've started to do now is either in conjunction with sort of the code writing or even before, we have the full Quint model, so we've started to augment that. And it's usually faster to just add to the Quint model and get some amount of certainty there and have that formal specification, and then be able to have just higher certainty that what we're building is going to be correct, and then we can jump into the code side. I think the other piece that's nice is somewhat internally, but certainly in the context of like external audits, having, again, this like really condensed, terse specification. It's much easier to talk about what's actually happening in the code, where it's happening. When it's, again, just spread across this huge surface area, it's harder to pinpoint, oh, this kind of area, but it also touches, this function, and if this gets called. So it's just a much more manageable way to both think about the underlying code and sort of discuss it.
Yeah, that makes a lot of sense to me. I do see that. I will go over to the next question. This one is, I guess you have to tell me. I don't know. I don't know how to solve this. How do you communicate the value of Quint to stakeholders who may not be familiar with formal methods, like with the people who have the money to pay for projects? How do you convince them to use Quint? How do you communicate the value? Like when the audit is done, oh, we use Quint on this audit. Why was it great? How do you communicate that to stakeholders?
Yeah. I think first and foremost, like both talking internally and then with like external integrators or people that are going to be putting their money on a exchange, just having as many possible things we can point to in terms of why we think it's correct, particularly in a system that's just so complex that there's not there's no simple way to prove that it's simply correct. Like all we can do is sort of the Swiss cheese approach of, we trust our engineers, we've had this audit, and Quint sort of adds one more stack of Swiss cheese to that. I think more particularly like why Quint is valuable. I think the unfortunate reality, and don't take this the wrong way, is auditors are fallible. The best I understand, I think there's a lot of, really good intuition in terms of looking at code and understanding where there might be hotspots or sort of having a good eye for and the right tooling for sort of catching some things. But the reality is, like, in a really complex system, it's very hard to, audit 100% of it, or certainly prove that 100% of the system has been audited. I think Quint sort of formalizes that process in a way. So again, like that first step of saying, one, we've recreated this entire system. So there's been, another set of fresh eyes that, have gone through this is incredibly powerful. I think just in the general engineering process, like when you look at code, you sort of, certain details can get hidden by the fact that it's already there, or there's something, say, deep in Cosmos SDK that has some unexpected behavior. So to just like replicate all of that in this stateless like functional environment uncovers things, and then gives us like much more powerful tooling to, in the case of like a smaller state machine, like being able to fully verify it is really sort of the highest possible validation for a system, assuming like the underlying Quint model is correct. In our case, where like the state machine is too big to fully verify it, it still goes like much further to be able to say, okay, we can, take 20, 30, 100 steps through the state machine across a huge range of inputs. The total coverage is just much better. And, I think it's just a really powerful tool to get as close to 100% verification. So I think that's, from the sort of more financial point of view, like without getting into, what is Quint? How is it different? Why is it, it's, for us, it's this tool that gives us a lot more certainty internally. And then, I think in terms of workflow, so sort of more internal stakeholders, obviously audits aren't cheap, and now it's a tool in our back pocket so that we can much more quickly like get to some degree of internal comfort with new features, and that's been really powerful.
Yeah, that's very good. Yeah, I need to improve my speech to other people about the value of Quint, trying to work on different angles to approach that. So it's interesting to see how you see and how you think about it. Thanks for sharing. Thanks a lot for agreeing to be here, Julian. Also, again, Giuliano. This conversation was really great. We do are at the last 10 minutes. We will have only like 5 minutes to go into the Q&A, but I think it's fine. I can answer the questions later in our channels. So do you have some questions for me, Ocean, from the link?
Yes, we can do the top two questions. There's some clear winners here. So the first one, the highest rated question is, do you think it's a good idea to use Quint outside of classic distributed systems, i.e. not blockchains, consensus, etc., but something simpler like client server?
Okay. So if it's too simple, so there is like a bit of a rule of thumb in general. Like I read about what Hillel suggests. So Hillel has a bunch of experience writing formal specifications with different companies, and he says his rule of thumb is if it takes less than a week to develop. So if the system you're thinking about specifying takes less than a week to develop, probably you don't need to use Quint, or you don't need to formally specify. Just go ahead. If it takes more than a week, then you might want to consider modeling it. In my opinion, like it has to have some degree of complexity to make it worth your time. And my particular like rule of thumb is like, can I feel insecure about this code? Like, can I feel like, oh, I'm not 100% sure this is correct. If I have this feeling of insecurity of like I'm not completely sure, and it is important that it is 100% correct, right? So some things are not important, right? If I'm writing like a video game with my friends, if it breaks, perhaps it's not a big deal. But if it is a big deal, if something breaks and I'm not 100% sure, if I feel insecurity, then Quint will help with that insecurity. So it will address that pain point that I have directly, and it will completely be worth it. Even like with out of blockchain, for sure, like out of distributed systems. I was just talking to April on LinkedIn before this. She was asking about like specifying schemas and like something more related to relations. And I was telling how I've done that with a toy example in the past. So there are definitely other areas, not only distributed systems, but distributed systems is usually where you have the most insecurity, right? So if you're writing stuff for distributed systems, you're like, oh, what if the orders are super complicated? What if this happens while the timeout, while the message is going and the message is dropped? Like there's so many scenarios. So it's usually where you feel the most insecure, but it's not the only area where you can apply Quint.
Great, thanks. And then the second question that rose to the top, does Quint support asynchronous communication between finite state machines, like with buffers, for example?
So Quint is very abstract, and you can implement that in Quint. So we do this asynchronous communication a lot. For example, any distributed systems will need some asynchronous communication. So you implement your buffer just like it can be a set of messages, or if you need ordering, then a list of messages, and it's just another state variable. So there are no like language constructs specifically for distributed system stuff or blockchain stuff or processes. All of the language is very abstract, and then you implement it however you want and however your system works. So it's not like it's ready for you. You go there and you implement it, but that's what we always do. And it enables you to work on a more abstract level than on the reality. For example, if you see some of the Lamport lectures, so Lamport is the creator of CLA Plus, very smart person. So he suggests that like some interchanging of messages can only be a set, and you don't even have to remove the message from the set because it doesn't really matter if the message is received more than once. So it's just like set of messages ever sent, and it represents them like that, and that is the best representation for that kind of system. So learning how to abstract away like this message exchange or synchronous messaging, communications between state machines, those are skills that you learn as you start writing Quint specs, and it's everything in a very abstract level. I guess we are at time, right? I will answer any of the unanswered questions. I have no idea how many there are. I'm promising something here, but I will answer all of them in the Telegram group later at some point. Don't promise that will be today, but if you want to join the Telegram group, it's this link right here. We do have some interesting conversations there, and I also offer a lot of support for people. So you see from time to time someone's asking, like, how can I do this in Quint? How can I write this sort of specification? How can I do this? And me and the rest of the team, we always try to answer as well as we can. So recommend that you join this channel, is where the action happens. And let's wrap up so I can let you all go. So just a few things, what's next on Quint Radar. Quint is already a good tool, it's already stable, we are already using it. It's already ready, but it will only get better from now on. So for the Rust simulator, we want to make it a default and then the only option as it stabilizes. So we are going to battle test it and then really use it as default. We also want to introduce parallel execution, so you can run like a bunch of simulations at the same time using the Rust simulator. It's quite tricky to do that with TypeScript, as you might imagine. With the Rust simulator, this will become true. We are also introducing soon the verification of inductive invariants, which are super powerful type of invariant. Usually it takes like, you have to run like 2 or 3 commands in a specific way to achieve this. But in Quint, we want this to be super easy. So we say like, this is my inductive invariant, and then it verifies it for you. Making our integration with TLC more user-friendly. Yeah, TLC is great. We want to have full integration with it, just as we have with Apache, which is completely seamless. More capabilities to Quint's language server. So language server is the thing that tells you when you type something wrong in your editor or helps you with autocompletion and that kind of thing. We want to add more features to that. We have plenty of ideas. And lastly, like also plenty of ideas to add to the REPL, like to load traces very easily, finding states in a very interactive way, and make it super, super amazing. That's on the radar, and you can support this. You can support Quint by doing this. So here are some suggestions on how you can support Quint. So first of all, you can contribute to our repository. Quint is fully open source. It's all there on GitHub. We just merged the Rust code, which came from a private repo, just because we are working on that for like the past 2 months, but now it's all open source again. And we have this examples folder. And this is a very good way of, if you want to learn Quint, You might want to write like a toy specification or a specific specification for your work, for your project. If you submit that to as PR for examples folder, I will review that for you and I'll give you feedback and then we can learn together. And also you can help other people that want to learn Quint in the future because they will see your example there and then that will help them learn, right? So that's a very good way to contribute. There's also TypeScript code and now Rust code, which you can contribute to. I'm more than happy to support any contributions, review your PRs, help you understand code base. So really like open source project contributions are super, super welcome. I'm super glad to have anything, even like to fix my typos, super happy. Spread the word. So the more people are aware that Quint exists, the more Quint will be used in the right opportunities. So it's super important that we have more awareness. So if you can, like, for example, post your thoughts about this event on social media, on your X account, LinkedIn account, that's super, super helpful. Tell your friends about Quint, talk about it. That's a very good way to support Quint. And lastly, giving it a start GitHub, because that number go up, very good for us. And if you want support from Quint, you can find us in the Telegram chat, as I said, or you can also open GitHub issues or discussions. I'm always happy to reply and to fix any problems you may find or help you understand something that maybe you didn't understand only from the documentation. And if you need some like professional help, dedicated help, you can partner with Informal System Security and Engineering Services. We have a very good team that knows Quint and that can audit your software using Quint. They can write a Quint specification for your protocol or for a protocol idea. And do all sorts of work involving Quint. The team is really amazing. So if you're looking for something like that, please reach out. We have this link here where you can contact the team and also this email. As I said, the team is really, really great and they will be super ready to help you with any Quint needs. Or if you don't want to do that, you can also just reach out to me and the team at the Telegram or GitHub. And that is it. Stay connected. This is my email if you want to chat more. This is my X account where I post a lot about Quint. We have Informal Systems website and then the Quint website where you can find all of the documentation. You also have the link for the demo that I did if you want to play around with that anymore. But we have a bunch of tutorials on the website as well. Thank you all for joining. I'm really glad to see you all here. This was a blast. I'm super happy to talk about Quint with any of you anytime.